This week we're going to start a guided project, and I call it a project because we are going to add to this project as the weeks go by and as we pick up new information from chapters 7 and 8. We're going to reopen this project and add to it and expand upon it. So this project is just a simple example of saving information into a file and then reading that information back out of the file. So up until now, everything we've done, we haven't been able to save persistent data. We've been able to save information in a variable while the program's running, but then when the program's turned off, we don't have any persistent data. So this allows us to save information into a text file. So I'm going to create a new project, call it last name first initial. I'm going to call this FilesIO. And I'm going to create a folder for it. And we'll just call it FilesIO. Okay. And my name. And the date. And description. This program will allow the user, I'm going to say this menu driven program will allow the user to save names in a file and then read the contents of that file. Okay. Using namespace standard. Oops. Okay, so as I mentioned, this is going to be a menu-driven program. I'm going to let the user type in an integer for what they want to do as far as the menu is concerned. So I'll create an int in choice, and I'm going to initialize it to 0. And that's because I'm going to create a while loop for my menu loop instead of a do while. And I'll say while choice is not equal to 3. We'll start with 3 options today and then add to that as we continue on. And I'm not going to get too fancy with my menu here, just some end lines, maybe in a tab space. And I'll put tabs after each number. And for now, the file that we will be creating, we're just going to hard code the name of the file directly into our project. As we expand on this, we'll give ourselves the ability to type in a file name. Currently, we haven't touched on the string chapter yet. Once we hit chapter 8 on strings and vectors, then we'll be able to do that. Okay, and then I'm going to use a switch case to process the user's choice. And we'll have our several cases here. not sure why the dev insists on cascading those. And then I'll have a case default in case they type something incorrect here. Oops. For now, I'm just going to put the break statements in there. And case 3, that's all it will have. And for the default case, I'll say something like whatever choice they just picked. Oops. Is an invalid choice. And I'm just putting comments here. The dev compiler is pretty good. Dev IDE is pretty good about lining these up for you and helping you, giving the little dotted line there to help you keep track of your curly braces. But it doesn't hurt to type comments like that. Okay. So it's always a good idea to if you've reached a point where you can run your program, then do, and just make sure what's there is working properly. At this point, we should just see our menu, and if I choose anything except for number 3, it should just spit the menu back out. Exit on 3. Okay, so far so good. So now what I want this program to do, as I mentioned before, I just want it to open a file and allow me to fill it full of names, and then also allow me to open that file later and read the names in it. So I'm going to create a new function. I'm going to call it add names, and it's going to be a void function. All it's going to do is prompt me for names and then actually do the work of putting those names into the file itself. Oh, I'm sorry. This is the function declaration. So all I need is void add names and then a little description here. And I'll say this function prompts the user for names and stores them in the file names.txt. So for now, we're going to have the name of the file hard-coded in. Later on we can change that. I think I already mentioned that. But something I want to mention here, the file extension, these are going to be stored as plain text, but you could give it any extension you wanted. You could have a specific extension for your program and call it IO, or you could call it just about anything that's not being used. And that's just how Windows recognizes the programs, of course. By calling it a .txt file, that will automatically associate it with a notepad. That way you can just double click directly on the file and it will know what program to launch in order for you to view the contents of the file. But you can give it whatever name you want here at the end, and it will, and as long as you just open it with a text editor, you'll be able to read what's in the file. You could call it .dat or anything really. Okay, so here in my case 1, that's where I'm going to call the function. Something that we need to get better on that I noticed after the test, when you declare a function, you have to put the return type, and then also if there's any parameters here, you have to list their data type. And then you've got a semicolon there. And you only have to declare functions when you try to call them before you've defined them. That's typical C++ format, however. That way you've got a list of all the functions and what they do in one place, and then you can use them as you need and just define them whenever you have a chance, or have room. So when you call the function, you don't put the data type in front. It's just the name of the function and then parentheses, and then if you need to pass any information. Now this function doesn't receive any data. If it was, let's say I wanted to pass like in choice to it, you do not put the data type. It already knows what in choice data type is from where we declared it here. So when you call a function, you do not put the data type or the return types. Okay, so add names calls the add names function. Let's define it. Here's the end of my main function. So void add names, I'm going to define right here. No semicolon at the end here, remember. And this function is going to open our file. And so the first thing I'm going to do here is I'm going to declare an object instance. Okay, so this is something you'll see in your textbook in chapter 6 around page 322, or I'm sorry, page 312 in the new text, and I'm sure it has a similar page number in the old text. I'll throw that up on the screen right now. And what an object instance is, it's kind of like a variable, only what I call them hypervariables. What it is it's a carving out a storage location that can store multiple pieces of data associated with whatever this object is, and then it also allows you to call the functions that operate on that data. So when I want to output information to a file, there's going to be data that's being stored about the file as we open it and close it, just information about its location and things like this, and all that information needs to be stored somewhere, and that's why we have to create this object instance. It carves out an area of memory where information about that file can be stored while it's open and closed and while we're using it. So certain classes force you to create these object instances before you use the functions in them. So now that I've created that object instance, I can call the open function and tell it what file I want to open. Okay, so this is called a member function. I'm using the dot operator. These are also items you need to pick up from this chapter. And I can't just call this function directly like I can other functions we've seen so far, like the functions in the math class, the power function. Those functions are static, and they are what are known as standalone functions. In other words, they can just receive information and then perform some task and then spit the information back to you, and it's not needing to keep track of any other additional side or metadata. It's just going to perform the power function. Now these other functions, opening a file, there's more to it than just, oh, here's the file name, where is that locate, where is it going to be stored, where is it located. All that information has to be stored somewhere, and that's why this class is a little bit different than the math class. It's a little more complicated, or a little more intricate, we'll say. So here we've created an object instance that allows us to call the member functions and then deal with the output file stream. Okay, and then I'm going to have the user type in some names, so I'll say add names, and I'll prompt the user. Enter a name to add to the file. We'll assume that they at least want to add one name, and I'll read that in. I haven't created a storage location yet, but let's do that now. And I'll just add that storage location up here, string name. Okay. Okay, and then I'm going to create a statement that will output the file to that, output the name to that file. So output. So the way this works, you use that file out just like it's the cout. So this is that specific file, and this is another reason why these the file or output file stream requires an object instance. If I wanted to, I could create several of these. I could have file out 1, file out 2, and I could just be outputting information to a bunch of different files. And by creating that object instance, we've got a name that we can associate with that particular file that's open, or that we've opened with that instance. And so here I'm outputting to that file the name, and I'm also going to output an end line to that file, which will serve as a carriage return. Okay. Now if I want the user to continue to type in names until I tell them to quit, then I'll need a loop here. So I'm going to create a I'll call it the storage loop. So while, and I'm going to let the user just type in like the letter Q if they want to quit. So I'm going to do while string name is not equal to Q. Something you may have noticed from this chapter, there's a 2 upper and 2 lower function that you can use on characters. And if you wanted to, you could create a separate statement and say, do you want to add another name, yes or no, or Y or N, and have a separate input for that. But that particular function only works on characters. So I'm just going to look at that string name and output to the file, and then I'm going to reprompt the user. So output to the console window, enter another name or Q to quit. To quit. So CN reads in from the keyboard, file out outputs to the file, cout outputs to the window, or to the console screen. Alright. And then a rule of thumb when you're dealing with files, you always want to make sure that you close a file that you open. So I'm going to do file out, and then the close method, or close function, is a member function of file out as well as open. Okay, so we can test this out. If I run this, the output file stream, I failed to mention this, it needs a new include statement, and it's the OF, or the F stream include statement. So include F stream. Okay, now it should recognize OF stream, and it does. Alright, try number 1, add names to file, enter a name to add to the file. Put my name, my dog's name, my other dog's name, and then maybe a Q to quit. There we go. Alright, and then after you've run this, the file should be created, and I think I already mentioned this. It is going to be stored in the root directory for this program, since we didn't specify a file location. Maybe I haven't mentioned this yet. Here, if we wanted to, we could type in the DOS pathway and tell it exactly where we want the file to be stored. And it could be a network location, whatever. But here, since I just put the name of the file, it will default to the location where this exe file is being created. So if you launch your Windows Explorer program and navigate to where your projects are being stored, here's my FilesIO, and there you see it, names.txt. If I double click on it, there's the names. And again, just adding the txt extension allows you the ability to double click on it without having to associate it with the file. But watch what happens if I call this .dat. I'm going to run the program again. and add names to a file. Let's use different names this time. How about John Bon Jovi? And then we'll quit. Okay, and in that same location, close the. Okay, in that same location, I have that txt file still there, but it created a brand new file, names.dat, and no preview available. It doesn't know what kind of file that is. If I double click on it, it'll say Windows doesn't know what this is. So then you can select from a list of installed programs, and if you just choose anything that will read text, Notepad or Notepad++, I think even Word should be able to read the plain text. So if I could open that .dat file in Word, and there you have it. Okay, so you can give it any extension. That's just you telling it what kind of file it is, and if Windows recognizes the extension, then it does. If it doesn't, then it doesn't. But it is plain text that's being stored in that file. I'm going to go ahead and switch this back to txt. Okay, next we want to view those names in the file without actually having to open the file physically. I want it to spit the names out to the screen. So I'm going to declare a new function, call it viewNames. We'll display the names in the file names.txt. Okay, so I've declared it here. I'm going to call the function here. Another word for that is invoke. You invoke the function when you're making a call to it and you're wanting to run the function. This says, hey, run that function. And we need to define that function. So down here at the bottom, and add names function, and create void view names. Okay, when you open a file to view names, you also need to create an object instance, but it's instead of the output file stream object, it is the input file stream object. And that may seem backwards. If I think of an input file, I think I'm putting stuff into the file, or output file. I think it's outputting information to me or whatever, but you have to view it in the terms of the program. So if the program, if it's an output location, then it's an output file stream. So that file is a location for output. For viewing the names, the file is going to serve as an input stream. It'll input data into our program that we can either view on the screen or do whatever we want with, store in storage locations. So I'm going to create an ifstream object, ifstream, and I'll just call it file in. And then same with this one, we have to open the file, and we call that member function file open from file in, and I'm going to open that same file names.txt. Okay, that opens the file. Then to read a line from the file, it's just going to be file in, and then we insert that and put that somewhere. So I'm going to create a storage location called string names. Okay, so notice file in now serves kind of like cin. It's where it's getting the information. Instead of the keyboard, we're getting the information from the file, and we're putting it into this storage location. Okay, and then if I wanted to view it, I could display it to the screen. So I'm going to have an output statement here. And inline. And then I'm going to read in the next name. And this is the part that I'm going to stick into a loop, something you should have picked up from chapter 6 as well is this end of file marker. This is a really good illustration of why you have to have an object instance when dealing with file streams. And file streams aren't the only cases. So this end of file marker, what's happening here is as you read through the file, this little object instance file in, it has information that it's storing internally about the file, and when the file has reached the end, there's a Boolean field in here that it turns to true. And so this end of file member function will return what's stored in that private data location, letting us know whether or not the file, or whether or not the state of the file, where the marker is at. Where are we at in reading? So these reading through these files is done sequentially. It's not done like a database where you can just pull out an individual row. You have to read through the file line by line. So that end of file member function is using some of this data that's being kind of held in private inside this little object instance. So that's what another reason we have these object instances. It can store metadata, if you will, associated with the file stream. Okay, so now I need to close my file. File in, close, and let's go ahead and run this and see how it looks. Okay. View names, maybe? Did I name it? Yeah, names. Okay. Typos can get you. Alright, so now I'm going to click 2 and try to view the names in the file. There they are. Now what would happen if I click 1 and try to add more names to that file? I'm going to put some different names in here. Well, I guess I did this one already, but okay. So now if I view that file, these previous names have been completely erased. When you open a file using this open method in the output file stream, it opens it in overwrite mode. Now if you want to be able to add to a file, you'll notice on page 322 in the new text, you have to add a parameter in here in this file out open. This is back in our add names function. You have to add this iOS definition for append. It's APP. So iOS : APP. That's append mode. Now if I run this program and then click add names to the file, and then I can add those names that I had before, and you will see now if I look at, or view the file, oops, I hit 1 again. Well, let's add one more name. How about you? Okay, so now if I view the names in the file, okay, now we have the ones I started with and the ones I've added twice now. So that's append mode, and probably what you typically want. You usually don't want your open process to be destructive as far as your data is concerned, or your add names. Yeah, you're adding names to your output stream. Okay, so a lot of information in this chapter 6. Be sure to read through it. Just a recap of things we covered here: creating object instances, and this is how they kind of introduce class structure. We're going to get into classes later on, and chapter 10, I believe. And then also member functions, how to input and output data to a file and input data from a file, and then the end of file marker as a part of that. So a lot of new stuff here. How Happy programming. Make sure you save this program. We're going to come back and add more to it as the weeks go by and as we learn new items from the new chapters. So be sure to keep track of this thing here. Happy programming, and make sure you know yourself.